Well, it's Friday and Free Energy Friday, and we're going to do some exciting overviews of a lot of different stuff. Lots of current events. We'll start with current events, and I'll talk about some old stuff about how I got into this all. And my background is in physics. Obviously, I got into all this stuff years ago. Devoted a lot of years to researching a lot of this stuff. So, but we'll start with some current events because this show's about all this kind of cool stuff. So, Glenn Beck had Charles Bueller of NASA on his show today with J.D. Vance. So J.D. Vance and Charles Bueller both on talking about science of how to overcome Earth's gravity without any rockets. So we're finally, getting this 25 years of NASA research out to the mainstream. But remember that it debuted on APEC first, right around Christmas time. So APEC is definitely on the map. It's a big part of this community. And I'm surprised it's not getting more attention from the community. Altpropulsion.com is our website for the APEC conference. Real easy to spell and find. We have a monthly, bi-weekly events. We have open mic events. We're trying to push the envelope forward with, just an exclusive club for talking about warp drives, anti-gravity, and theoretical physics, moving the human race forward. So that APEC was amazing. And super historic. So, and a lot of these are historic as well because, for example, the interviews that we did with, one of the first one I think we did, the very first one was with Mark McCandlish. Yeah, the second APEC we did was with Mark McCandlish, who died right after that. So that's historic because it was one of the last interviews that Mark McCandlish ever did. So we get to ask him tons of technical questions. It's like the best interview that you could ask for because it's like literally a team of this awesome community of researchers and speakers that come together and just tear nonsense apart. So when people talk about Gibbs free energy and thinking that's the kind of free energy that you need, and that once you'll have a battery that just stays alive. It stays alive forever, you know what I mean? So I don't know. Anyways, that was just a joke. In any case, other jokes. If people want a real funny joke, this has been going around recently, and I just had to laugh at this. I actually have to thank Ashton because I wouldn't even have known that Charles Bueller was on Glenn Beck if I didn't, read his posts on Twitter, which have gotten a ton of attention. The real deal Neil comments on it 7 hours ago and says, "From what I can tell from their website, I think you're way ahead of these guys." And Ashton Forbes replies, "Way ahead, period. It helps to wake up normies, though, period. It's wild how secretly advanced the defense contractors and military is." I don't know if I don't know whether I should take Ashton seriously. Like, he thinks waking up the normies, like we're normies and we're waking. I don't know. I don't get it. And that you're ahead of Charles Bueller, man. Like, Charles Bueller dropped like 25 years of like straight up NASA research on us, and it's like we're still going through it all. And I got some replications on the way here. That we're working on, and if you want to donate some time and energy instead of doing these live streams and making videos promoting some free energy device that you just heard and just learned about on Ashton Forbes has got all this free energy device now, and he's teamed up. I don't know if you've seen all this. Actually, I should put all this on here. Well, we got it, and then I'll show you guys around the lab and show you a couple more stuff. But yeah. So yeah, the Charles Bueller thing was cool. I'm glad that that's getting out there to the mainstream. But Ashton's gotten this huge following. I guess he was on Glenn Beck and a couple of these other big shows and stuff. So he's gotten himself like 143,000 followers. But from what I've seen and understand, this whole MH370 videos really have fallen apart. A lot of debunks have come out from professionals and stuff that are just tearing it to shreds. I'm not going to get into the videos and stuff. That's not what we're into on this channel. But I do think it's funny that, Ashton was just learning what sine waves were and getting into Tom Beard. And if you go back 2 weeks ago, that's what he was posting about, just learning about some of this stuff. And now he's an expert and he's way more advanced than us. Within 2 weeks, he's surpassed, all of my physics knowledge and all of Charles Bueller's and all. Yeah, this is the device too. Apparently, there's another video. It's just like these wheels with these magnets on it that supposedly produce free energy. Like we haven't seen 100,000 of these before on PES Wiki and other forums and stuff way back in the day. I think it's laughable, dude, that Ashton would say that about Charles Bueller and the APEC group when he's not even an amateur, not even a mediocre physicist or engineer. I don't know. I'm sorry, Ashton, but that's like a way overstep of everything, and also when I first interviewed you, I pretty much said I think that those MH370 videos were fake, but it doesn't overshadow the fact that we should be looking for warp drive technology and the ability to teleport things. Yeah, if we can teleport stuff, but man, saying that it's real and promising people that you got free energy or that you can do quantum and macro teleportation and unification of physics and stuff is it's a little I don't know. Anyways, the NASA debrief article on Charles Bueller really put it out there, and then I'm glad that Ashton has at least drawn attention to some of these other fringe physics ideas and stuff. Ashton was on Glenn Beck, and then Glenn Beck has Charles Bueller on. That's always I guess good for us if we're getting more eyes on what we're doing, the less likely it is for them to shut this kind of stuff down. So that's good disclosure. I just don't understand quite what Ashton's motivations are with what he's doing, but it is okay that he's introducing people to these subjects, and even if he is, I guess, making a kind of not doing it as much a good service to the topic, so the subject matter, so to speak. As you know, I've been researching free energy claims and different technologies. I did a whole thing on with coldfusionnow.org back in 2011 to 2019, and we did. I went and filmed a whole bunch of lectures at MIT. Met Mitchell Swartz and Peter Hagelstein, and then I went back for the 2019 Lanner Cold Fusion Colloquium Conference and documented that as well. And those videos can all be found on the Alien Scientist channel going way back. Talked about I interviewed there were some really interesting people there talking about fractal metamaterials and fractal some of these ideas. The last time I talked to Mitchell Swartz from MIT, that he was working on cold fusion cathodes that were using nitinol metamaterials, and that's the last I've heard from him. So that's super interesting. If he's was working with nitinol metamaterial and stuff. But anyways, yeah, there's lots of cool, really legitimate scientists working on cold fusion. I thought it was this whole pseudoscience realm, and I thought it was like all bullshit because of that guy Rossi with that ECAT and all that stuff that seems to just take all the attention away from all these other legitimate scientists who have legitimate papers and work and publications and research that's worth looking into. So I covered all that in the past. Yeah, Jet Energy was Mitchell Swartz's company, the MIT scientist there that was doing the nitinol metamaterial stuff. But anyways, yeah, this is all stuff that I've covered in the past. You can go back and see my videos on free energy. The stuff that we're working on currently with the free energy is these two scientists. You can go. There's Tim Ventura has an interview with Danny Sheehan, not Danny Sheehan with the curly hair that does the aliens, that did the Watergate and all that stuff. The JFK expert there, the lawyer, not that Danny Sheehan. There's another Daniel Sheehan, and he works at University of San Diego, and he talks about in this episode something called Maxwell's demon, which all these free energy inventions that like Ash and Forbes are going off with, right? These are based on known processes that with thermodynamically are impossible. They just defy every known conservation law of physics in the whole universe. They just don't conserve energy. We know about thermodynamics, about building machines. You have an energy source, and then you can only capture some of that energy on its way to a sink, and there's only a certain amount of efficiency. And these are just based on the governings of these quantum mechanical processes. And it's just normally accepted as a law because people have been building machines for hundreds of years and just observing this. And every engineer knows these laws and learns them and is drilled through them until they have no creativity left by the time they're done with engineering school. But there are some scientists who are brave in these fields, like Danny Sheehan of University of San Diego. And another one that you guys should check out is Dr. Garret Moddel. And Garret Moddel, this is Garret. Garret Moddel has some really far out interesting ideas. I don't agree with everything he says. I don't agree with him on his remote viewing stuff or some of the other things we do disagree on. But I think he of all the PhD professors, scientists doing legitimate research and talking about this, he's out at the University of Colorado, and Garrett's doing great work. He's at least pushing the envelope in a lot of these fields, a lot of these ideas, and he's got some really interesting systems ideas for engineering the Casimir effect for, various things. And he talks about the physics of it. So if you want to get into all that, I would watch these lectures first if you're into just watching the stuff, or if you're the super scientific hive mind, you just go right to Google Scholar and search Garret Moddel and Danny Sheehan, University of San Diego, and Garret Moddel out at University of Colorado. So check those guys out. They're doing some really awesome cutting edge research. We're actually trying to replicate some of that work here at our lab, which I'm going to disconnect, and I'm going to just minimize that so I can show you for a second what we're working on here. So this is the Danny Sheehan kind of device, and it's basically these reservoirs of two different pH solutions, which are carefully calibrated, and then they cross on this Nafion membrane, this stuff called NaFiON, and the Nafion membranes will actually produce a voltage across it based on the pH difference in the two chemical reservoirs. And so these are 3D printed, and then they go in the soaking solution bath of DI water, so that we can really make sure they're absolutely neutral and sterile, and before the experiment. And we're measuring some voltage. I don't have all the specifics on this because I'm not working on that project personally. I got a couple other projects that I'm still doing right now. But this could potentially be a battery a way that you could just turn make large battery reservoirs from chemicals in the future. One idea for it. This is the Charles Bueller setup. We're trying to make electrets to do the Charles Bueller thing, and we've got this airbrush gun, which we have a electrode. We're gonna use this high voltage source to charge up the airbrush gun, which we're going to fill with a solution and spray it onto these plates, and then make electrets with that inside of this glove box, which is going to be a climate controlled chamber, which we're going to electrostatically charge to increase the amount of electrons and ions that are being trapped inside of our electrets as we produce them. What else? Oh, we got this project that we're working on for the shive wave generator that should be done in maybe another couple couple weeks or so. It's going to take us a while to still put a couple of these together. The idea is that we have 100 of these devices that are going to sit on. These are going to be your shive waves, so they're going to be balanced along this axis, and it's going to be like a shive wave generator, except you can change the parameters of it by pulling it in or pulling it out to change that that moment of inertia value, the I. That I term. So anyways, what these will do is we'll make a big shive wave generator with 100 of these, and we can parametrically drive it by oscillating and changing the parameter functions rather than the typical way of that waves work. So it's going to be pretty interesting wave science experiment once we can get that going, and that's in collaboration with some universities locally. And that'll be great. We got a whole team of professors and students working on this from WPI, and then we got this Charles Bueller replication we're going to be doing soon. Once we get a couple more parts in, we might have to custom make some things. We were just discussing some design ideas. We're going to try a couple things out. Michael suggested some ideas. And here's Michael now. Hold up, let me bring him in. So,
hey, yeah. Oh, sorry, my hair's a little messed up today.
Hey, Michael.
Yeah. So, I just heard you talking about things. Lots to clarify there. So you should pull up is this StreamYard? I guess maybe you could present the wave generator. But a shive wave generator. It's just a wire rod with a bunch of wire rods welded to it orthogonally and symmetrically around an axis. So when you hit one end of it, the torque produces a wave that travels across these individual bars next to each other, like And so, Jeremy, if you could look up that, you on your phone there, or
yeah, hold on 1 second. I'm going to bring it up.
Yeah. That's really something that requires a picture. Yeah, here you go. So it's a picture's worth 1,000 words here. So if you have a bunch of these rods and they're just attached to a central rod like this, then you can get this traveling wave. You can do all sorts of wave physics demonstrations with the basic equation of a
Yeah, and it's great because you can do the wave math because you can model each bar as a discrete point in the function. So
Yeah.
you can it helps you with to understand and conceptualize the math, and then constrained and unconstrained boundary conditions.
Yeah. So, anyways, that linkage we made is like one bar in that array, and each of the linkages changes its moment of inertia and its stiffness, and those are the constitutive parameters which determine the wave speed and also impedance. But we mainly just change wave speed in that experiment because they have to change inversely to each other in order to just change wave speed, and so they're 90 degrees from each other in that linkage that we have for the wave machine. And so each of those segments is individually actuated and externally controlled by an ESP32. And so it can change its, it can locally change the wave speed in whatever pattern you want to study. And so it's a teaching tool. Anyway, as for Dan Sheehan's work, it's based on Vladislav Kapek's book, Challenges to the Second Law of Thermodynamics. They go into detail in the statistical mechanics of that there. But yeah, basically that thing, there's a bunch of different ways that do this. Like Garret Moddel's got this metal insulator metal diode with a Casimir cavity, and that biases the metal insulator metal diode so that it converts thermal energy into electrical energy. Supposedly, we will see. I think Garret Moddel's original device was made of aluminum and titanium or something. So with those sorts of materials, it's very difficult to completely get rid of oxidation as a source of energy. Yeah, here there's the Casimir gap on one side of it. So
yeah, I gotta find that image. I know the one you're talking about.
It was just there. No. Earlier, yeah, maybe. Huh. Oh, maybe that was it. The yellow. No. Anyway, it doesn't matter. The point is overall that yeah, that's the one. That was the one. Oh, yeah, this still works. So the point is a metal insulator metal diode will form an equilibrium state across the boundary, and this Casimir cavity on one side of it kind of throws off that equilibrium. And so that's the idea is you get this, and then they were saying they were getting 70 watts per square meter out of this thing, which seems like a lot. So we'll see. But that one's relatively easy to test. I mean, we're talking about like a nano layer of insulator, but you can do certain etching processes that'll produce a nano layer, especially on like titanium and things like that. And then the transparent dielectric layer is about 30 microns, so that's completely achievable. You can even do 20 microns these days with certain tapes. You could probably just use Kapton tape and then metalize the outside. But in any case, there's a ton of ways of doing this. It was unclear whether this is required to be a small surface area per diode, but the Casimir cavity can be a single Casimir cavity at least, so you can have an array of diodes underneath there, maybe. I think. Well, point with all of these devices is that you're taking thermal energy and you're rectifying it back into useful electricity in some way or another. So you've got like one thermodynamic ensemble which settles into some steady state distribution that's not just completely thermalized. There's some gradient there, but it's at some like the action principle has been minimized or maximized or whichever, and then you introduce something into that system that throws that equilibrium, that throws that action. Like you change the action of that system in some way, and then that allows you to create these things called non-equilibrium steady states. And well, then the Unlab on YouTube talked a bunch about it. So like they have a lot of good videos if you want to go into it. Stephen Wolfram was there. So as for our particular device, the ionomer, the Nafion ionomer, we don't use Nafion anymore. We're using Fumapem and Fumasep. But point is, you have some membrane, in our case, a bipolar membrane.
What is that? How do you spell it?
Bipolar membrane?
Oh no, it's a bipolar membrane. But all right, no, I don't mind. No,
Fumatech is the company.
That's too technical, I guess.
Think. Let me just double check.
So you're not using Nafion anymore?
No, Nafion's old. Fumatech is a. They're very.
Fumatech, CU.
That's I put it in.
How do you spell it?
I put it in the comment in the chat in the StreamYard, but
oh, Fumatech.
Yeah, it's like a. I guess it's a German company or something. I wasn't sure. GmbH, yeah, that looks German. But yeah, they produce very large quantities now these days, so they're starting to replace Nafion in many applications. This just the scale of their production allows them to take over the market a bit. But it doesn't really matter. At the end of the day, you have a positive and a negative ionomer, and these are like salts that are bound, or acids and bases that are bound to a polymer backbone. And so they want to neutralize, but they can't. They're sterically hindered from neutralizing. So that produces a steady state pH gradient across the bipolar membrane. And so on one side, you'll have a lower pH, on one side, you'll have a higher pH. So yeah, you get this pH gradient. And then the key thing is you have to poke a hole in that membrane, and if the hole is small enough, so I should preface this. Ionomers form little nanoscale tubes through the. If you dump an ionomer into water, the polymer backbone is typically hydrophobic, and the functional groups are hydrophilic. So they'll tend to form tubes through the water, through the plastic when it's just soaked in water. Actually, Jeremy, if you look on Google Scholar, you can probably find pictures of this, or even images. What would it be? Ionomer. Ionomer in water structures maybe is general enough. No, that's not what you should search for that, but okay. Just try Google Images. That'd be the easiest. Yeah, here you go. See, there's a. Oh no, that's polymer crystallization. Let me see if I can find you a picture.
A lot of dentistry stuff, applications for it, for ionomers, I guess.
It's not as easy
to find work.
Dispersants for single. Maybe I can. Capillary structures.
I gotta find a better term to search Google Scholar for.
Here we are. Maybe. Nope. Well, I guess I don't know why that would be hard to find, but we can do that some other time, perhaps. Point is, the functional groups are hydrophilic, and the plastic or the polymer is hydrophobic. So the functional groups all stick out into the water, and they form these little tubes of water that go through this. But those are at like the nanoscale almost, at most like a micron, very, very small. Um, so if you then drill a larger hole, specifically much larger than these holes are nanoscale or barely micron scale, and because of that, they're mesoscopic at most. The mean free path of the water molecules is similar to the diameter of the channel. So that means that the adsorption chemistry on the channel wall will somewhat determine the ion concentration in the liquid. And so at the boundary between the liquid and free space, or if you have a larger body of a reservoir of liquid on one side, you have your tube, and you have your reservoir of liquid on the other side. And so one caveat is that the salt you're working with has to be able to freely exit the tube without too much difficulty. If it binds too strongly to the tube wall, if the adsorption chemistry is too strong, then it'll get stuck in the tube and it just won't come out. So there needs to be ion exchange at the interface between the reservoirs and the inside. But if you have that, then you get this pH gradient through the whole thing. So assuming you have the correct salts and assuming you have the correct ionomers, then this happens. So now if you make a larger hole, which is multiple microns across, 15, 20, 30 microns, maybe even 40, it's large enough that the mean free path of the water is tiny, and generally speaking, the ions will prefer to recombine, and they won't be affected much by the walls of the ionomer. And so you get this flow back of you get some separation of pH with the small tubes, and with the larger tube you get a flow back and recombination, and that happens continually, driven by thermal energy, just at one ambient heat path. So that already technically would make some people uncomfortable in terms of the laws of thermodynamics.
Yeah, it's like a second law violator, right?
Well, yeah, not yet. So if you then put electrodes on the two sides, and they also interact catalytically with the salt solution, basically if they have a different electrode potential, then there's these flowback channels that are cut through the ionomer where an electrical current can flow. And so you have these two things at a different voltage, and you have electrons that can pass through. And so you get this, you get a little bit of a battery-like effect. It's not easy to optimize. That was Dan Sheehan's earlier plan. Nowadays, they're doing something a lot simpler, which I think maybe we should follow their lead in that. But basically, I mean, a lot of people have played around with like Joule thief circuits charging lead acid batteries. So if you pulse current, DC current into a lead acid battery, it will look like the lead acid battery is charging more than it actually is. And typically that's because of some changes to the electrodes. Now, Jeremiah mentioned that these things actually do have more power than the input power, which I thought that didn't make sense to me for the longest time, but something new, we found something new recently that suggests that this should be the case. So there's this new thing MIT just put out, and I think a few other papers are published so far, called what was it? The photomolecular effect. Photomolecular effect. And so the idea with the photomolecular effect is just like the photoelectric effect. So if you have a metal with an electron gas, then photons can hit that electron gas and they can cause an electron to come off of the metal surface.
Ooh, the paper was withdrawn.
Oh no, already?
Yeah.
Huh.
Well, this one's
Revised
from
23 April 2024. That's weird. But there's a bunch of other papers about it too now. There's a ton of these. Exceeding the thermal limit, yeah. 2023, yeah, there's a bunch of this. So anyway, this photomolecular effect is just the same thing as electrons, but it's with water molecules. So if you have a surface of water and you have photons that come in and they hit the surface, then it's possible to eject a whole water molecule off of that liquid, not due to the standard evaporation, but due to just the light interacting with the water. So let's say you have a UV light and otherwise it's completely dark. So you turn on your UV light and you turn off your UV light and your water evaporation rate will change measurably. That's the idea here. So what's interesting about the photo, so basically what I suspect is going on now, so Dan Sheehan's moved on to this other thing. Maybe I should let him talk about it. But I suspect it uses the photomolecular effect. And the interesting thing about the photomolecular effect is it's unexplored so far, for the most part. So the photoelectric effect, the minimum work function for a material that's stable in air is 0.5 electron volts. That's for calcium aluminate electride. Which I typed in the chat for you, Jeremy.
I'm gonna search that on.
Hey, Bernie was here. Oops, I missed him.
Electride.
Yeah. Yeah, they're using it on the space station these days. They have they use it for the ion thrusters. But anyway, they just the electrons come off and they neutralize the ions on their way out. So anyway, this stuff has a work function of half an electron volt. That's extremely low. So you can get electrons to boil off of this stuff just by heating it to 300 Celsius, and then already enough of the Boltzmann tail is above 0.5 electron volts, where you get electrons evaporating off of the surface, basically. So that's cool. The photomolecular effect, in principle, you could have you could have interactions much lower than 0.5 electron volts. So that's really exciting, because if you can find a photomolecular effect combination of materials, two different liquids, two different gases with some interdiffusion coefficients, and the energy associated with the photomolecular effect is like 0.25 of an electron volt or something of that nature, then now you're talking about something that you could basically harvest thermal energy with. So you would have like a boundary between two liquids or some liquids and solids, and you would have a capacitor that self-charges potentially. So that's huge. That's a huge thing. Anyway, I just wanted to mention that. That's this photomolecular effect. There's going to be a ton of applications of this.
Yeah, that's awesome. How is that different than what you talked about with the what we're making this graphitic carbon nitride, and
that's called photocatalytic water splitting. So
photocatalytic water splitting. That's different.
Yeah.
And is that related to what Terrence Howard was talking about with the, he used the frequency of beryllium to split water or whatever?
Not at all. That's so what you're doing here is you have typically a semiconductor particle with a catalytic surface. So molecules adsorb to the surface; they get stuck on the surface, and then it's a semiconductor. So like with those gallium arsenide quantum dots, if you look up gallium arsenide quantum dots, and they all fluoresce, or just quantum dots. That will do. You can make like a rainbow out of them. Do they have?
Sorry, images.
Just go to quantum dots. Maybe they're better. There'll be better pictures if we just search quantum dots. Yeah. So different sizes. You have different fluorescences. But that's the idea. So you have these. Typically, they're a little bit larger than quantum dots, just so that they don't immediately decay and release light. You want to hold that photon. You want to hold that exciton on the particle as long as possible until it interacts with adsorbed chemicals and splits them. So this is basically artificial photosynthesis. That's what this is. And so if you have this semiconductor particle, it can split water. In principle, electrolysis is 70% efficient. In practice, there's a lot of work to be done. Like I think photocatalytic water splitting is like 5 or 10% efficient. But like it's on the same curve as solar cells. But all it is you're adding powder to water, and then you're producing hydrogen gas, which you can separate centrifugally with and then you can just so you would need some flashback arresters and things, but all you really got here is like water tanks. So
you're producing Brown's gas, it's hydrogen and oxygen mixed, right?
Yeah, it's hydrogen and oxygen mixed, but so you'd have to unmix them. Mm-hmm. So that is one possible danger with something like this, but that's engineerable. So you would unmix the hydrogen, you just let the oxygen outside, and then the hydrogen would just go in some pipeline, like an oil pipeline, back up to where it's required, up to like some energy plant. And then with this sort of method, you could cover a desert in these thingamajigs, and you could pipe the energy thousands of miles away. So this, like solar cells, the reason they haven't coated like the Sahara Desert with solar cells is because of transmission losses. You'd have to transfer that power over electrical power lines to somewhere where it's needed. So if you just have a pipeline with hydrogen in it, then carefully designed, I would say, you'd need a lot of flashback arresters for that, and a lot of anti-static. Yikes, Well, actually, no. It's like the Hindenburg. If you were in the hydrogen compartment, there was not enough oxygen to have an explosion. So,
what about mirrors and just capturing the light? And like, I was thinking.
Oh yeah, and that's actually you can do this and that. So there's solar thermal energy. So you have mirrors and you concentrate the light onto one spot, and then you heat it up to high temperatures, and then you produce steam to power a turbine.
Yeah.
With this technology, you could add the photocatalytic material to something like that, and photocatalytic water splitting, up to a point, it works better than so at higher temperature and higher pressure, at least until you lose the semiconducting properties of the material, it will continue to split. So, and it'll split more efficiently too. So now you're producing steam and you're producing hydrogen, so you're getting more gas expansion, and then you can harvest the hydrogen afterwards. But I think that sounds like that sounds a little technically complicated. Ideally, you want something that's scalable like not overly complicated so that you can scale it well. So I don't know.
So of all the super smart engineers and stuff working on these energy problems, if it was easy enough to just put a bunch of magnets on a wheel and get, make free energy, would they be spending like this kind of money on this infrastructure?
I mean, technically, Charles Bueller's thing would do the same thing. It's just electrostatic instead of magnetic. But yeah, I mean, you could make like a pinwheel with that, and just it would, according to what they're saying, it would just start spinning.
Yeah.
So I don't know. It's a very weird time to be alive. I guess we'll see whether Charles Bueller's thing is legit.
Yeah, and Ashton Forbes. We'll see whether Ashton comes out with the real free energy device, or Terrence Howard or one of these guys.
Indeed.
I mean, I am curious. I'm curious to see if there's a magnetic analog of Charles Bueller's device. Because like the one interesting thing is, Jeremy, we've got like neodymium magnets. Those are very strong. Also, magnets hold their charge a lot easier than electrodes. So I'm kind of curious to see if we make a magnetic analog of Charles Bueller's device with the field structures all the same, will that still induce propulsion? We could probably build something like that like tomorrow if we wanted to. I don't know. We'll see. But actually, that would be an interesting test, because that would say that would actually prove that the quantum vacuum is made of electrostatic monopoles, not magnetic monopoles, which I guess is almost a given considering what we know about physics. But I mean, it's really not something that's been probed in an open source way yet. So that's interesting.
Well, did you see Neil Tyson did a response to the Terrence Howard?
Well,
will we at least get some laughs?
Well, the Dunning-Kruger effect. Yeah, yeah. I feel bad. I should have reached out to Ashton before he fell in with this crowd. And
yeah, this is like it's exactly word for word what's happening. What happened with Terrence Howard and all those people is like exactly what I seen happen with Ashton.
Yeah, in this field, like if you don't start out with enough physics knowledge, you're up a creek without a paddle. And that's just unfortunately how it is. It's just you're not going to know.
Yeah,
it's like in a more general case, like I've been very blessed in my life. I've been able to go to many countries and see what it's like there, But a lot of people, maybe they've never left the United States. Maybe the only thing that they can rely on to know what the outside world is even like is propaganda and news media. Like, that's some special hell right there.
Yeah, and
like, what do you do? How can you possibly know what's real if you just don't even have the funds to ever take a vacation somewhere?
Understand it, to be able to build it, test it, and then apply changes to then see what actually happens, to actually get a basis of what you're doing, not just completely clueless and taking someone else's word, right?
Yeah, basically, yeah. It's and just and generally, like, if you start your life and you're already being sold lies by the news media, it's turtles all the way down. Then I wonder if we're the last, like with AI now, I wonder if we're the last generation to have ground truths.
Yeah, it's crazy. I definitely feel bad for the people that are just getting into a lot of this stuff, and this is like one of the reasons we have to keep this channel and this stuff alive. This is just so it's like it
Jay
seems like
Decker,
a lot
splitting
of the
water
stuff.
doesn't need any additional electrons. I can verify that I've actually come up with the process with zero electricity in, just a couple of zinc plates and copper wires connecting the water that produced hydrogen nonstop, like at a much slower rate, mind you, but still producing hydrogen without any electrical input. So,
Well, that's just galvanic corrosion between the zinc and the copper, though.
yeah,
Mm,
but it's the
yeah, that will
basic of it
produce.
building.
I mean, they use zinc and magnesium uh, as ship protecting electrodes. So you'll get a chunk of zinc and magnesium, and you'll put it on the bottom of a boat, and it will prevent the like propeller and other components from corroding into the water over time, because the magnesium gets corroded first.
Yeah, both of them are very soft. I found things like tungsten and silver actually last exponentially longer than those metals on the opposite sides.
Oh yeah, for sure.
So I have not been keeping up with the whole Green Year
Oh.
thing. What happened? What's he doing now with this?
Before we get into that, what was the deal with Ashton Forbes' device? Is that just a magnet motor, standard magnet motor?
Yeah, apparently some people found out another video of it, and they said it was. He's saying it's not the same thing, but other people are saying it's the same other known free energy scam. So
that just looks like magnet gears.
Yeah, he hasn't shown a lot of.
What's on the top of that?
So Ashton did a video on YouTube. Let me just go to his thing and see if I can find the video where he's. So there's a video here where it got a lot of views, and I'm gonna find it real quick. That's the one that had it in it.
Oh.
Yeah. No, not that one. Damn it! I must have went by it already. But he's sharing a lot of our stuff too, and using it with kind of like out of context and saying that I don't know.
Yeah, I mean that's something to watch out for potentially. I mean,
I don't know where it is.
It's like artificially kind of associating this with all the BS stuff, even though we've taken great pains not to be associated with any. Well, I mean.
Yeah, I mean it's out there.
That stuff.
It's not. It's hard because they see alien scientists and they immediately think, "Oh, this is all that BS shit." So it's
right. Well, we'll see how it goes. I mean, we've got enough research going on here that like some of these free energy devices that we're working on. Well, not free energy, like non-equilibrium steady state devices.
This is the same thing he showed, dude.
Some of these magnet motors are pretty interesting, actually. If occasionally you'll see one that is like lensless, and if you see a lensless motor that's properly done, it's actually a switched reluctance motor, where the switched reluctance comes from an array of LC tank circuits that are properly timed. So basically, you have some toroid coil, and when you put current through the toroid coil, you're using up some of the magnetic susceptibility of that ferrite. There's a magnetic field looping around the coil, and everyone's gone except me. It's one of those days. Well, anyway, I'll continue whatever. So is it my show now? Basically, I guess. Huh?
Sorry, my apologies. I was setting up the other Free Energy Friday episode where I have Faraday Research. I got Old Man Builds Nathan. I believe
Nice.
Tim's joining us.
Cool.
And Benefit Beneficent TV, also second channel Benefactors, joining us for a second day. He's been reproducing the PoE coil, the Peace on Earth coil by One Stop Energies, Daniel and his wife, the Nunezes. And in
Nice.
his coil, he's been able to get 130% or 137% return through feeding it back over Unity in it. He's going to be doing some more live tests and showing it. As well as Mike and Gerald are also going to be there. I sent the link to Jeremy this morning. I was hoping that he would join. Mike, I need your email, and I hope that you're able to join and come on over for a little bit too, because what you're saying is like the realist of science, of the most applicable, most likely viable free energy sources.
Ever the connector. I like that about you, Bernie. So, but yeah, before we jump to that, and it sounds like a lot of cool stuff there. One of the things I always see is like if someone gets like 130, 150, 170, up to 200% efficient, typically when it's in that range, it's just someone who is not familiar with power factor corrections for measuring power in electronic circuits. So like you cannot, when you have the phases overlapping in different ways than the standard way, then there's some reactive power in there, not just the real power. And the reactive power never.
Mr. Boyd, I meant to send it to Boyd too, but here he is on this one, even better. And
so, but yeah, I mean, so one thing to look out for is reactive power in those circuits. But before we, hey, we have more people. Nice. Hey there. So yeah, Jeremy, I was telling people like. With these magnet motors, there's one case where it is interesting. Let me see if I can actually find the video to go along with what I saw. Let's see. Lensless motors. Let's see if we can find a real one.
Guy passed away on
Tuesday. Yeah. I'll move on from this. Anyone? I invited Ashton to come on.
Welcome, Mr. Ashton's on traveling to the Cosmic Summit convention right now, so he's not able. Welcome, Mr. Boyd. And if y'all don't mind, in like 5-10 minutes, if we could shut this down and just all hop over to the link in the private chat.
Yeah, no problem. I'll be joining up with you in a little bit over there. I was gonna shut this down soon anyway, because I gotta get going. But I'll try to join up with you in like maybe an hour or so.
Yeah, for sure.
All right.
We'll be going for a bit. Mr. Boyd, when this does end, in your private chat, I posted the link to hop over to the other free energy stream that we'll
This went really good. I don't want to keep it going much longer than an hour. We're almost there now. I know Michael my boy Mike Boyd just joined.
I didn't know how long you guys were going to be going. So
yeah, no.
It is what it is.
Good to see
Yeah,
you.
no, but we killed it on a whole bunch of cutting edge science on what people should look into if they really want to do the research into this and be part of this field and push it forward and not get sucked into, stuff that's just going to discredit us.
Well, the over Unity part caught my attention because.
Yeah. Well, so if you're curious,
that perpetual motion, and that's a red flag.
Right. Well,
Yeah.
it's not. It's a non-equilibrium steady state. It's not perpetual motion. Once you suck out all of the thermal energy, you're back to just the ground state.
Well, my idea of over Unity is you get more power out than you put in.
Okay. Well, that's.
So
Really?
yeah, you can probably do that for a short time, but there's it has Basically, everything equals out in the end.
Right. So anyway, lensless coils. Real quick thing. I don't know. Unfortunately, I can't find the video again right now. But if you have a toroid with a coil around the torus, and you have a number of these around some magnets in your rotor, so that you have these as a stator, you've got a bunch of toroid coils. If you excite the toroid coils, the magnetic susceptibility of that toroid coil to external fields goes down. So you have a switched reluctance motor, and if you have all of these coils hooked up to LC tank circuits, then they're not using any of their own power. So they're just a tank circuit. You're going to have a little bit of resistance in the tank circuit, but you're going to be changing the magnetic susceptibility by a large amount. And so this magnet comes around the loop, and it gets more or less attracted to different magnets, and it keeps spinning around. And that energy, that's an interesting question about, like, is that producing some over unity? But
isn't that just a hysteresis effect that you're talking about, which is it's a magnetic hysteresis?
So you have the magnetic
for a certain amount of time, it's over unity, but then it goes the other way.
Quite possibly.
It depends on where you're looking at it in the hysteresis curve. You follow?
Right. Well, so the hysteresis curve has some area under the curve, but you could use a super paramagnetic material, and then you have minimal area under that curve, and most of your losses are just in the resistance in the wires. But what's interesting is, okay, so if you have, let's just say you have two magnets, and they're toroid coils, so they don't have external magnetic field. So what happens if you set up these two tank circuits so that they're 90 degrees out of phase, and you put a magnet in between them? It's going to vibrate back and forth between these two. But, well, I guess maybe there's the hysteresis is nonlinear, so you're going to change the energy in the tank circuits somewhat based on the position of the magnet in between them.
And then one tank circuit's going to be the opposite polarity of the other tank circuit.
No, the tank circuits are toroid coils, so they don't have external magnetic field beyond, like, it's a loop of magnetic field inside.
But there's a crosstalk between the two, correct?
Barely. There's almost no mutual inductance. So if you assume each is a pretty good toroid coil, then the vast majority of the magnetic field is inside the toroid. But if you have another magnet outside, then the force on that magnet will depend on the magnetic susceptibility of the two coils. But the effective susceptibility will change when when each of the toroids is magnetized. But anyway, yeah, that might still be.
Is that your idea? Or is that someone else's idea that we can look up?
Well, I just saw people doing that with lensless motors, and I was like, that's interesting.
Okay.
But I'm sure other people have thought of that.
Interesting. Well, I got to wrap.
Well, I mean, it's just a parametric effect, really. It's like we've been talking about with the, like, but yeah, I mean, the switched reluctance motor is a common type of motor, right? But if you have these toroids and they're just tank circuits, they're wasting like no power changing their susceptibility. So then you just have to time them, each of the tank circuits, to switch at the right time. And you've got a switched reluctance motor where you're not using power to change the reluctance.
Okay,
you're minimally using power.
There's another discussion that's starting up right now, correct? And that's what this link is for, the other link that you have in the chat?
Yes, sir, Mr. Boyd. Please use it and come on over. We got Tim Ventura, Mike Faraday, Gerald, Phil Bouchard, Benefactor, and a few others. So it's going to be good.
I'll stop by, sure.
Please do.
Okay. You still got to send us some
I pulled it up, and I'll sign off this one so you guys can be in your hour. But sorry I missed.
Oh, no worries. We'll be starting right away on the other. Much love, and thanks for having me. Look forward to seeing you all there.
All right, we're going to be talking about this and other awesome stuff. But we'll move everything over there, man. All right.
Okay. Have a good night.
Much love, guys.
Water burning hybrid. Oh, this cool water burning cars. These are always interesting.
I got a hold of this guy. This video is 14 years old. He messaged me back today on YouTube. So he said he's doing an update, and hopefully we'll get him on. And
nice.
Also talked to my mechanic. He's getting a car with the carburetor, so we can try rebuilding it too.
Oh, Jeremy, do you still have that NASA paper where they're like electric discharge produces more than the chemical energy input?
Yeah, that should be in the stream from the Terrence Howard night. It should be posting the links in the info on that stream. I'll email it over to you.
Arc liberated chemical energy exceeds electrical output. I've got it here.
Yep. Awesome.
Yeah, that one.
That
one's
was
an
cool.
interesting paper. That's also probably relating to some parametric behavior. So the thing with parametric stuff is, I've heard this term with Tom Bearden and some other folks of like regauging. So what is regauging? So you're changing your gauge fields in some way that the real power in the system has now changed. What might that look like? So in space,
you mentioned like you're switching your permeability and permittivity.
Yeah. So if you have a material and you change the impedance of that material with respect to time instead of space, then if you have a traveling wave through that material, then you'll have a reflected wave from that, and the reflected wave plus the transmitted wave has greater than the original wave's energy in general, if the impedance is different. So that's interesting.
We'll leave it at that.
Yep.
All right. Have a good night, everyone. Thanks for watching.
Yeah, Friedrich Morgenthaler's paper was the guy for that. Velocity modulation of electromagnetic waves. He didn't want to talk about impedance, but his work implied that. Anyway, yeah, have a good night.
Well, we will bring it over to the other stream, and I'll check it out. Oh, all right. He posted a link. Awesome. We'll check it out.
Cool.
All right. Thanks. Cool.
Have a great day.
Have a great night.